Okay, so this is question 4 on our final. This question, we have to answer: how quickly is the distance between the mouse and the rat changing? And first, we have some givens. So some things that we know. The first thing that we know here is the rate at which the mouse is moving, and that is at 5 feet per minute. We have the rate at which the rat is moving, which is 8 feet per minute. We have the original distance that the mouse is starting at away from the meeting point, which is 100 feet. And we have the distance which the rat is, or how far the rat is away from the meeting point, which is 50 feet. Now, because the prompt asks how quickly the distance between them is changing and they're coming together, that means that the distance between them is going to be a negative, like it's going to be dropping. So the C is going to be larger at the end, or as time progresses, it's going to get smaller. So it starts larger and gets smaller. So because it's getting smaller, the rate at which the distance changes is going to be negative. That's why this -5 and -8 are going to be negative. So the information that we need to find is the rate at which the distance of C is changing, like how quickly the distance between the mouse and the rat is changing. We also need to find the original distance for C, which we can do through a simple a squared plus b squared equals c squared, and I did that right up here. So I took the original distance of the mouse, the original distance of the rat, and equals c squared. We know how to do this. C equals radical 12,500. So we're going to do another Pythagorean theorem because this is a 90-degree angle. And we're going to take the derivative of it in order to find the change in the derivative of C with respect to T. So we start with our a squared plus b squared equals c squared. And to take the derivative, we're going to take this 2, and we're going to put it down and have it be a coefficient here. And obviously, when we take a derivative, we're going to drop the power by 1. So it'll just be a power of 1, which won't really show up. So now we have our a, which is our m, so 2m, and then we are putting it as the derivative of m with respect to time. And plus 2r with the derivative of r with respect to time equals 2c, and the derivative of c with respect to time. And so we're gonna take the m value, which is 100, and we're gonna multiply that by our rate, which is dm over dt. So our rate is -5. So 2 times 100 times -5 plus 2 times 50 times -8 is -1800, which equals 2c and dc over dt. We're going to plug in our value for c, which was radical 12,500. We're going to divide both sides by 2. And then we're going to divide both sides by the radical 12,500, and that gives us our changing rate, or the change in the distance over time. So this is a speed with the direction, so we can give it a negative sign. It's a velocity. So dc over dt equals -8.05 feet per minute. Yeah, so that's number 4. I think I covered everything. I don't know if there's anything I missed, but yeah, I think that's good. Sweet.